Yeah, flange.
Yeah. We're going to try and figure out how to do graphing of polar form equations on Geogebra. Okay, here's the first trick. You go to options and see where it says settings. Options, settings. And under graphics, it has, here's your types of graphics, right? That's the X and Y axis. I want to somehow come up with the type of axes that we use in polar. Remember what that's called? It's under advanced. See, under advanced, we could change from degrees to radians, but I'm going to keep it in degrees for right now. You'll see. Some people are more comfortable thinking about 90 degrees opposed to pi over 2. Where is that exactly? Now, there's something else, though, and it's not in advanced, apparently. Where did it go now? Oh, the grid. The grid, we could have a Cartesian grid, an isometric grid, and what that is. Oh, you see it?
Wow.
Yeah. Or the polar grid.
Yeah.
That's what we're looking for. Okay, save the settings. Now we've got ourselves a polar grid. That looks nice, right? Now, mine looks a little distorted. How does yours look up there?
It looks fine.
Okay, great. What's this point right here?
2 at an angle of 0.
Okay.
Or 360.
Let's try plotting that point. 2, comma, 0. Huh. It's graphing and polar, right?
Yeah.
2, comma, 90. Oh no. It's not interpreting that as 90 degrees.
Because
it's still plotting points. It's still plotting like 2, comma, 3. All we've done is we put the grid up. It's still thinking in rectangular. Now, I still haven't found a way to find out where is it hiding its whole rectangular mode of thinking. I've even tried, maybe if we said 2 and look for an angle. You see an angle marker in there?
Yeah. Never mind. You can, use degrees.
This?
No, degrees right here.
Well, that's degrees, though.
Yeah, just change it.
You want to change it? Okay, fine. We'll say 2, comma, 90 degrees. And, no. Apparently, it took 90 degrees and converted into radians, which is about what?
1.5.
1.5. So it's still, this was just not working for us here. So that's one of the problems with Geogebra, but we have a solution. What are your 2 components in polar form? The angle and the r magnitude, right? R and angle theta. And John had this idea of r cis. We could just put down r cosine theta, r sine theta every time. But it's not accepting theta as a variable for me, because when I put an r equals something theta, it just didn't graph. Watch. If I say r equals, like one of my favorites is sine 2 theta. 2 theta. You see, it doesn't know what theta is. It doesn't know what to think about it. So I'm going to tell it what theta is. I'm going to come over here to a slider and actually put a slider down right here. And I'm not going to call it A, I'm going to call it theta. So you hit this little alpha symbol to get all your other Greek symbols. Theta. And I'm going to have it go from 0 to 360 because that seemed to be all our plotting techniques, right? 0 to 360. And again, the increment just every 15 degrees for now, because those are special angles, pi over 12, pi over 30, and that type of thing. I'm also going to have the slider be a little longer. I found that 100 is kind of a short slider. Let's go to 600 and apply.
Yeah, don't you have to change it to angle, not number?
What do you mean? Like where did it say angle?
On there.
It's like a check box. Like, go
Really?
back.
Okay, I'll go back to here again. Object properties. Under basic or under slider?
No, it's not there.
It was like on the left, one of the things you could click on next to where you click the theta.
Yeah, go to advanced. No, it's not there.
We'll be off. It works. I tried this.
Oh,
I tried this. I tried to see. It's working. We're getting all these angles, right? And our mode is degrees, because we saw that before, right?
Yeah.
So now it should accept this. r equals sine 2 theta. And it says r equals 0. Why? R equals 0 because if you put 0 into sine 2 theta, you get that. Now notice, it doesn't show you the formula, but here's all our other answers, right? And notice how it's changing between, it's working, because it's going between -1 and +1, right?
Yeah.
Where could we get our maximum value, though? Shouldn't that happen at 45? No. Sine 2 theta, when's that get a maximum? I thought at 45 degrees, and I thought it was hitting 45. Hope that's not an error. We said sine 2 theta, right?
Yeah.
And 45 degrees times 2 is 90. Sine of 90 is 1. What's this 0.89 stuff?
Uh-oh, spaghetti-o.
Now, let's look at this again. Object properties. Basic. It's r equals sine 2 theta.
Maybe you should recreate the slider and we can see if we should have that.
We should call it an angle instead. Okay.
Yeah.
So close, and we're going to make another slider. We're going to call it theta.
And then angles on the left.
Okay. It's an angle. All right. And there's the 0 degree. Oh, thank you. Okay, that's nice. In terms of nice angle then. Okay.
Wait, change it back to alpha.
Oh, it changed back to alpha? Okay, we want theta.
And it's the increment. It's probably because you've already.
Yeah, I think we want the increment in degrees.
Yeah, it's probably because there's already a theta.
There's 15 degrees. No, it just calls this one, and what we can do is we can get rid of this. We can get rid of this. We can get rid of this theta 1. Take it, delete it. Okay. So now we can go back to this one too and also fix the other property. That is, I want a bigger slider. This is the width? No, we want it to be like
600.
600. Okay. There. Now we can slide that puppy around, right?
Yeah.
And now we can say r equals sine 2 theta.
Cross our fingers.
Why is it giving me grief on my battery? And now when you slide this around, r changes. And look, at 45 degrees, it's at 1.
Yeah.
So it spins all the values, okay?
Sure.
Okay. Now,
Yeah.
we already said that it didn't graph an angle, did it?
Right.
Okay. But it'll graph a point.
Yeah.
And what's your conversion formula to get x and y from r and theta?
X equals R cosine theta.
And
Y equals R sine theta.
so x equals r cosine theta. It might freak out on that r times thing.
Better not.
Comma r sine.
Mr. Lynn,
Yes?
is there like a way to get rid of the thing that's on the screen? Like, no, it's
Yeah.
like on the, it's on the
Here.
screen and it's on the bottom, and so we can't really see what you're typing in.
Thank you. That's a good idea. We have to put a times in here. It's just not a times, a times, a times. Is that a times?
Yeah.
Okay, it looked like a caret. Okay.
Don't care.
Invalid, undefined variable cosine of, okay, fine. Boy.
If cosine theta is 0, then.
Well, I think what it didn't like is that it was looking up for the name of some function. Okay, oh, picky.
Go.
Hello.
Yeah.
We got points, right? Now, this is one of the polar guides at 0, because r equals 0. And we get some other polar guides somewhere else. And now you can see how the angle is related to the graph
I
there, right?
remember the.
Now, I think you should be able to stretch this out a bit.
Trace the points.
To the stretch, to the
Oh,
stretch,
oh.
to the stretch, stretch.
Oh, what the...
What happened, Mr. Lynn?
We have to zoom in a
Zoom
titch.
out.
Okay.
To the right, to the left, to the right, to the left, to the right.
What the...
Schneid.
Zoom in, right?
Yeah,
There we go.
it's getting better. Yeah.
graphics view like this. Okay, this should be better now, right? Now, good suggestion, Jerry. What'd you say? What'd you say? Under object properties, you want to trace the point.
Right, yes.
Oh. Yeah.
So now you grab your slider and it puts all those points in for you.
Oh, that's nice.
Okay?
It looks like a butterfly. It does.
Now this is what I mean by the polar guides. When does it equal 0?
At
It
0, 90,
At 90 it's equal to 0.
180, and
Yeah.
270,
At 180 and 270. So in this case, the axes themselves become our polar
and
guides.
360.
And 360. Now, how do we get more points in there? See, this is the points you could plot. But what are the key points here, you think?
We chose the 15-degree increments to 40.
These peaks, right?
One at an angle of 45.
Yeah, one angle 45, right? 45 degrees, and over here, and over here. And you'd see those peaks if you just graph R equals sine theta, you get 2 cycles. And so you get a total of 4 petals here because of that. Now, let's do 2 adjustments here. Those are the key points. Let's get all the other points in there by going to this.
Changing the increments?
Changing the increments, we can do that on here by object properties. I want to change the increments to every 1 degree. How's that sound?
0.1.
Oh, depends.
0.1 degree? So it just wants a lot of stuff.
0,
in
0, 0,
there.
0, 0.
Also, let's just change the color here to red. And here's why. I want to show you what happens if I stay between the first 2 polar guides. From 0 to 90. Oh, you know what? Hello. I changed the color of this. I want to change the color of the point. Change the point to that. Okay. Now we go like this. Hello, we're doing the red part now. There's that 45-degree peak, right?
Yeah, that's a nice.
There, oops,
Ah,
see there.
daisies.
So this red section from 0 to 90,
Looks like an ear.
it looks like a little
It
ear.
does look like a.
And notice the direction it's going into as you trace it. It starts here, and now where do you expect the next section to go?
Like there.
Where?
Like that. Down to this,
Okay.
the 4th
We
quadrant.
got to shift now. We got to shift to blue.
Oh.
Brewer's colors.
Red and blue. Okay, thank you very much. Okay. But notice how it doesn't go. We're going from 90 to 180. Why isn't it in the second quadrant?
Because it's a negative number.
Right.
That's
Because
what
the
the
R's are
is.
negative right now. And so that's why it kind of flips down here. But it actually makes more sense, like you're doing the clover leaf at 43 in brown deer.
Yeah.
I've seen some people do this. They should not be doing that. It is not a, what do you call it? An amusement park. It's one of the most dangerous types of intersections you can encounter in driving. Clover leaves. I don't know why when they fixed it, they kept it. They made it a little better because there's more lanes now.
Yeah.
But you basically have counter merging. People coming off the highway and people trying to get on the highway are merging counterwise like this in that same lane on the top of the bridge. It's very dangerous. Okay.
Oh, at that way.
All right, so now what happens between, what happens, and here we are at 180
Then
then.
it goes that way. To the 3rd
Now it's going to keep going down to there. So let's shift to green.
The one over there.
So we can take it the rest of the way now. And there's our green section. Notice, Joe, I think we got enough accuracy with every 1 degree. Okay, you don't get it.
Now let's go to the second quadrant.
And now we better go to some Olympic color.
Yellow.
Yellow. Black.
Black. What?
They have black in there.
Hard.
No.
Titanium.
Yes, I think yellow. How about like a gold? Ew. Baby throw up color. Oh dear. Oh, there we go. And there we go. No, that's the color of my house ledger. That's ledger house.
Ledger!
Crash!
Ledger!
Okay. So see how that works?
Please, no
Very nice, right? Edit graphics view to clipboard. I'm going to put that somewhere. Now it's time to change everything, right?
To what?
Well, we can just change this R. change the number r, change the properties, and we can explore other types of functions.
No.
Oh, sure. What if you go 1 plus
Oh, whoa.
Sine.
Well, then
2
see
sine
what-
theta?
Oh, snap.
Getting a little tricky here.
Yeah, now, and you okay with this color?
Yeah, it's fine.
No, I'm not. Oh, wait, yeah, we have to go to the colors of the point.
Make
Make
it
it
red.
nice.
Blue for
Kind
brewer.
of like, okay.
Purple.
Here we go now. How do I get it to go? I want to go back to here on the slider. Okay, starting at 0. Oh, good. Starting at 0, we're over here. But check out the bizarreness here. What the?
What? That
Oh
looks
my
like.
God.
Oh my god, it looks like a bug with wings.
Oh my gosh, it does.
Why aren't the petals
You know what?
symmetrical
It
now?
looks like a polar graph.
They are symmetrical. Along
Yeah,
with
they're symmetrical.
Where does it
on
show?
the back.
Yeah, oh yeah, those two are, but these other two aren't.
What do we graph?
We're laughing 1 plus 2
they're not
sine theta.
1 plus 2, no.
No, sine 2 theta.
Well, because when it dips into the negative thing, like the.
Yeah, 1 plus 2 sine 2 theta.
1 plus. Oh, well.
So what would help us here is something called the polar guides, because notice how before we said the x and y axes were our polar guides and we didn't cross them.
Yeah.
We're crossing the x and y axes now, aren't we?
Yeah.
Because you raised it up by 1, some parts stayed underneath and made little petals in the opposite direction, and some parts went up and got even bigger and started incorporating more than just the first quadrant. So this petal has more than just the first quadrant in it now. So let's find out where these polar guards are, and that's where r equals 0. How can we find out where r equals 0?
We can.
Maybe take a quick aside here. That was our first nice graph. Where's Control V? Oh, there it is. Yes. Remember what our equation was? R equals 1 plus 2 sine of 2 theta. Let's solve it. How can you solve this on your calculator quickly, folks?
Solver. Not.
Graph it and then do like the mathematics.
When does 0 equal 1 plus a new sine theta?
Oh, you can graph 1 plus 2 sine theta and figure out the x.
Well, when does sine of 2 theta equal to negative a half? You've done these before. You do this by hand, right?
Oh yeah.
So 2 theta, just take a quick moment here. A little alignment moment. Breathe into your nose.
Yeah, but Jack
You were
was
supposed to
bad.
give it to one of us.
So 2 theta equals, when does the sine equal negative a half? What are those two angles?
Oh, 210 and 330.
So 210 plus 360 n, right? We're like it all. Or 2 theta equals 330 plus 360 n. So theta will equal half that, 105 degrees plus 180 degrees times n. And theta equals 150, 165 plus 180 degrees. So at 105 degrees, at 165 degrees, at 285 degrees, and that's just 180, let's stick with that, right?
Yeah.
And also at 345 degrees. Okay. Those are the polar guides. And that's easy enough because those actually line up with some of the things on your polar graph paper, so you can put those in. On Geogebra, we can't just, this has an easy polar equation. It's just theta equals 105 will give you the angle like that. We, on the other hand, have to do something clever, though. Yeah. How do I get the line that has a slope of 105 degrees?
You do.
Remember the tangent of the angle is the slope? You're right.
That was Tiwa.
Tiwa?
Yeah,
There you go.
Tiwa.
Tangent of 105 degrees times x. And there's your polar guide. Right? I'm going to go ahead and make that dashed.
style.
You get really thick.
So there's one polar guide. And notice how it helped us with the other angle too right away, right?
Yeah.
Because they're 180 degrees out of sync with each other. What was the other graph?
65.
Yeah.
I thought we already set the mode to degrees, so why do we have to keep on using degrees?
I don't know.
Okay.
Because,
Geogebra's kind of crazy.
do you want me to change it?
No, it's okay.
I took it out. Let's see if it still works. See? That's why. Okay? Thanks, Tila.
Sorry.
Now we gotta go back to the equation. Back to basics.
I'm sorry.
Oh my goodness.
No, I thought that too. Why would this mess us up? But, you know, it's interpreting that as not an angle, but just as a number, so it goes back to thinking of it as a radian.
Yeah.
I guess that's why. Why didn't it just let me do my slider before with the other thing? You can be a little finicky.
Clueless.
And sure enough, that's the other polar guide.
What about
Okay.
the other angles though?
What are the angles?
Like the plus when you add 180.
There.
Right, that happened to be in line with this one, right?
Oh.
So what if you had a polar guide that was just in one angle, but not the one opposite from it? That'd be a little trickier.
Yeah.
Okay? How do you graph something like that? You could put a restriction on your y equals. You could say, for instance, on this one, you can put an if statement down. If x is less than 0, then do this. And that way you'd only get that part of the line. It's an if-then statement. A lot of times you'll find this pattern though. The polar guides are in like opposite directions from each other, but not all the time. Okay, how do we get this filled in more then?
Go slower.
Go slower?
Or you do a locus.
No, we
Increments.
object properties.
Can you make the
This is the guide now, right? The increment should maybe every 0.1 degree. Okay, now we can fill it in more.
Kind
This
of.
goes-
You have to go
I think
slower.
we get
There you go, Joy. Is that better, Joy? Look at how it's stopping there. Won't go. It's because we went from 0. You have to be careful sometimes because the nature of the, what do you call it, period of the polar graph, 0 to 360 might not cut it for you. It might not give you the whole picture. And you might have to go a little beyond, right? Okay. Thank you, friends.
Thanks
That's
for
it.
joining.
Yep. Flange out.
Flange out. You gotta finish the pics. Okay, there we go. There. Now, you can get yours to look a little finer by making the point size smaller. If you're doing this on Geogebra. But I think it's a nice way to present your homework then off of Geogebra and print it up. Or you can send it to me as a Geogebra file, but it's probably better to print it up, maybe even in color, and I'll scan it. Okay, that's flange out. Oh, here we go. Stop. Stop.